Okay, so what we're going to do right now is we're going to talk about powers and exponents. So they go together. An exponent is part of a power. We're going to define that. We talk about what it is. Then we're going to talk about two of the properties of powers in this video. So there are well, there's more than this, but say six. There's about six that I'm going to talk about in the next two videos. And the two basic ones are most basic are product of powers property and the quotient of powers property. They both um, follow directly from the definition of exponents and powers. And so let's go ahead and get started by defining it. So a power is a number with an exponent that tells you how many times that number is used in a multiplication. So if we look at b, and with a small n up here, this is read b to the nth power. N is our exponent, and then b would be the base. The power is the whole thing. Now the way it works is that this exponent tells you how many times to multiply to use this base in a multiplication. So for instance, if we have 3 to the fourth power, the base is equal to 3. The exponent, I'll abbreviate it, is equal to 4. And 3 to the fourth power is equal to 3 times 3 times 3 times 3. So we're going to use this in a multiplication 4 different times. And that's what a power is. So again, small number up to the right, the superscript, that's an exponent. The larger number is the base. And we're going to be working with these two properties. In both cases, with the product of powers and the quotient of powers, we will be talking about them when using the same base, because these are not applicable. They do not work when you use different bases. So let's just go ahead and think about what we've got. We'll use the same example here, 3 to the fourth power. Let's say we're going to multiply that by 3 to the second power. So this is one power. This is another power. So this is what we're going to be talking about when we say product of powers. Product means the answer you get when you multiply. So the product of powers property is going to be give us a rule to find out what the answer is. So to do that, we can look at this and write it out using the definition. So 3 to the fourth power is just 3 times 3 times 3 times 3. So we're using that 3 4 times in the multiplication. Now we're also using this 3, right, with two different numbers, 2 times in the multiplication. So if you break it apart like this and then count it and ask yourself how many times is this base being used in a multiplication, altogether it's 1, 2, 3, 4, 5, 6. So the base will still be 3, and now the exponent is 6. So the way you can, if as long as you remember the definition of power, and you should always be able to figure out what the product of the powers property is just by making up a simple example like that. And so the rule is this: b to the n times b to the m. So we have two different exponents. They could be the same exponent, but we're going to write it as two different exponents. The rule is to keep the base, add the exponents. M plus n plus n, m. It doesn't matter what order you add, right? So that's our base. That's our property. So the product of powers looks like this. Okay, so that's just using what you already know about multiplication, and that's how you get the answer. Okay, now quotient of the powers would be something like this. Let's say we take 3 to the 5th power, and we're going to divide it by 3 to the 2nd. Let's go ahead and use that again. Now, instead of using, we can use this, but it's going to be easier to see using it with a fraction bar, and you should get in the habit of using a fraction bar when you divide anyway. So we've got 3 to the 5th divided by 3 to the 2nd power. Now, just like we did up here, we're going to use the definition of exponents and powers to rewrite this. So we end up with 3, well, in the numerator, we're going to use that base 5 times in our multiplication. So we have 5 3's. In the denominator, we have 2 3's. Now, for each one of these pairs, 3 divided by 3, we know 3 divided by 3 is equal to 1. So we can cancel that out and replace it with a 1. We can cancel this out, replace it with a 1. So now we have 1 times 1, no 3's in the denominator, 3 times 3 times 3. So 1 times 1 is 1, 1 times 3 times 3 times 3. Here we have 3 3's used in multiplication times 1, which is the same as 3 to the 3rd power. Now notice what happened here. We have 5 minus 2, that's what gives us a 3. So our rule for quotient, and I should keep this separate, that's from the top part, right? The quotient of powers property is going to look like this. B to the m, b to the n. When you divide, we're going to take these exponents and we're going to subtract. Just like that.